Very good morning to one and all. Myself, Avinash JL, Assistant Professor, Department of Electronics and Communication Engineering, SVCE, Bengaluru. So today we'll discuss the brief history about the transistor. So in that, the first we'll discuss about the invention of the transistor. So you can see that the vacuum tubes ruled in the first half of 20th century, large, expensive, power-hungry, and reliable. So still we are using the vacuum tubes the first half of the 20th century, but they are very large in size, very expensive, and they will require the more power, and reliability is also very less. So in the 1947, the first point contact transistor happened. So that particular thing happened in the John Berdine and Walter Brattain at Bell Labs. Okay, so you can see in the figure, okay, so it is something like a crystal fire, how it is going to happen. So now, when you're talking about the types of the transistor, okay, so bipolar transistors, in that bipolar junction transistor, we say, so your NPN and PNP silicon structure will be there. That means what? NPN transistor is one type, PNP transistor is another type. Those are made up of silicon structure. The small current into very thin base layer controls large currents between the emitter and collector. This is the fundamental thing what we know in the bipolar transistors. The base currents limit integration density. The base currents limit the integration density. That is one of the disadvantage in the bipolar transistor. So here the metal oxide semiconductor field effect transistor. The next type of transistors are MOSFETs we say. Okay, MOSFET, field effect transistor, the metal oxide semiconductor field effect transistor. So in this particular type, there are subtypes like NMOS and PMOS. That means what? N, that means what? The electrons, N negative. Okay, P means positive. So NMOS and PMOS MOSFETs are available. So the voltage applied to insulated gate controls the current between the source and the drain. The voltage which we apply to the insulated gate control, it is particular control the current between the source and the drain. The low power allows very high integration. It is a low power alloys and very high integration is available in the MOSFETs. So when we understand that there are some good advantages than good advantages of MOSFETs than the BJT. So obviously we choose the MOSFET, okay, for integration purpose on the single silicon chip. So we can see that MOS integrated circuit. So in 1970s, the processors usually add only NMOS transistors. So here NMOS transistors are inexpensive but consume more power while idle. So here NMOS transistors requiring the more power consumption when they are in idle. So here I can see that there are two diagrams. That is Intel 1101 256-bit SRAM. So how it is been designed and how it is been happening in the single piece of silicon. So Intel have developed that one, and later Intel have developed that Intel 4004 4-bit microprocessor. So in that I can see that how much integration and how much evolution has happened. Okay. So and after that, in the 1980s, the present, okay, 1980s to present, CMOS processors for low idle power. So that means what? From the year 1980 to the present day, we can understand that CMOS is the technology which is ruling the world. CMOS processors for low idle power, we are going to use it instead of NMOS. So that is the advantage of CMOS once again. So when we are discussing about the Moore's law, okay, so Moore's law, so then we can understand that in 1965, okay, Gordon Moore plotted the transistor on chip. So how the increasing, okay, That means what? How much for the same space, how many transistors can be incorporated? Okay, so that is what exactly the concept here. So here you can see that fit a straight line on semi-log scale. Transistor counts have doubled for every 26 months. Okay, so you can see that in the x-axis we have taken the year, and the y-axis it is something like log 2 of the number of components per integrated function. That is what exactly is being given. You can see that from the year 1959 to 1975 it has been given. So the things are getting in the linearly, it is increasing for the same space we are talking about. So that particular graph, it is indication that how much we are in the technology, how much we are into the technology, and how much how much space has been reduced. That is a very, very important thing we need to understand. So that particular graph and that particular concept is been given by the Moore. Today, the Moore law is a fundamental law. Okay, without Moore law, we should not study the VLSI subject only. That is what exactly the concept. For any designer, for any student, for any professor, Moore's law is a must. We need to understand it, what exactly he's thinking. So you just imagine in his age, he is thinking in this particular fashion, how much genius you are there. So next thing is what when we're talking about the integration levels. So in that point in the space, okay, how much depending on the number of gates or depending on the number of components, we can classify the integration levels, okay, into the 4 sub levels. So in that particular 4 levels, sub levels, there is the first sub level is SSI, that is small scale integration. So, and the second one is what medium scale integration, and the next one is what large scale integration, and the further next thing is what very large scale integration. So, when I'm talking about the small scale integration, it is 10 gates. So the number of gates are very less, that is 10 gates. Medium scale integration is the 1000 gates. Large scale integration is 10,000 gates, and very large scale integration is more than 10,000 gates per same space we are talking about. So you can understand that initially we are in the SSI, next we have moved to MSI, next we move to the LSI, and the next we move to the VLSI. There is more than 10,000 gates which are available on the same area. Okay, so that is what exactly the thing. So and now I can see that year wise, okay. So transistors wise, you can see that when in the year 1970, okay. So 4004, okay, the processor Intel 4004 were there, and 8008 was there. So in the 404, it was having the number of gates between 1000 to 10,000. Okay, so and in between below the 10,000, that is 8008, 8080 was there. So when talking about the 8086, so it will 10 to 10,000 to 1 lakh. And so that the keep on increasing, you can see from the year wise, okay, number of transistors. So later we have 80286, and later we have Intel 386, Intel 486, and Pentium processor, Pentium Pro, Pentium 2, Pentium 3, Pentium 4, Pentium M, and Core 2 Duo and Core 2 Quad. Okay, up to particular thing we have been moved. Okay, so this is the graph. Okay, so how much it is increasing? See, when the things are getting increased, so you can see that the evolution of components with respect to the technology also it is going to happen. You can see this particular graph and you can understand the things. Thank you for listening.